Hello everyone, and we are on algebraic expressions chapter 7, and this is going to be simplifying algebraic expressions, a key skill for both GCSE and A-level. So we've got a couple of questions here to have a look at. Okay, so the first one we've got to simplify is x squared minus 1 over 2x squared plus 7x minus 4, and that whole thing is multiplied by 6x squared minus 5x add 1 all over 3x squared minus 4x add 1. Now, if this is GCSE, this could conceivably come up on a non-calculator paper. So as that's the case, we'll talk through how we're going to multiply, how we're going to factorize all of these various expressions, okay? Well, the kind of easiest one is this expression here, okay? Sometimes students get confused by this first one and they're not too sure what's going on with it. But if I think about 1 as being 1 squared, then you can see that it is the difference of 2 squares. So x squared minus 1 squared factorizes into x minus 1 times by x add 1. Okay, so that's our first bit there. That's quite nice and straightforward. Let's deal now with each of the others. So we've got 2x squared add 7x minus 4. And I'm going to use what I've often heard to as the ABC, or sometimes the rainbow. I've heard teachers call it the rainbow split method, which is kind of sweet. So what we're going to do, here's the rainbow. So we go 2 times by minus 4. So that means we're looking for two numbers that multiply together to give us minus 8, but add together to give us the positive 7 that is in the middle. Okay, so that factor pair would be positive 8 and minus 1. So positive 8 times by minus 1 is minus 8, and positive 8 add minus 1 is plus 7. So then you split. So we've done the rainbow, and now it's time for the split. We split this middle term into 8 and minus 1. And it's interesting to note with this method that it doesn't matter which way round you put the 8 and the minus 1. It makes most sense to put the 8x here and to put the minus x there. However, it's worth noting that you would get the same answer even if you split it the other way. Okay, so we now have 2x squared, and then what have we got here? Minus 4. So now, with this method, we just factorize that bit and we factorize that bit. So we look for what can come out of 2x squared minus x. The highest factor that can come out of that is an x, leaving us with 2x minus 1. We can take out a 4 from here, so plus 4, leaving us with 2x minus 1. We know that this method is correct when these two brackets match each other, and whatever's written in front of them is the other bracket. So therefore, this factorizes into x add 4 times by 2x minus 1. Okay, so we've done that one and we've done that one. Let's have a look at, we're going to do the same rainbow split method for all the others. Other methods are available. For example, you might find it easier to just do the whole thing by inspection, which is fair enough actually, but I just like this nice algorithm because it always works. So we do 6 times by 1, which gives us, we're looking for two numbers that times together to make 6, and they've got to add together to make minus 5. So two numbers that times together to make 6, but add together to make minus 5 is going to be minus 2 and minus 3. So they times together to make positive 6, but they add together to make minus 5. That's the rainbow bit. Now it's the split bit. Again, it doesn't matter, but it makes sense to put the minus 3x there because you've got a common factor of 3 with the 6x squared. And we'll put the minus 2x here, plus 1. Again, we now factorize these two separate bits. So let's we can take 3x out of the first one, leaving us with 2x minus 1. This bit sometimes confuses people. We can take a minus 1 out of this bit here. So when I take minus 1 out of that, that leaves me with 2x minus 1. We know we're good because these two match each other. So whatever's written in front is the other bracket. So 3x minus 1 is the other bracket, and we have 2x minus 1. And that is that one factorized. So just one left to do now, just this one here, which is 3x squared minus 4x add 1. So we're going to do our rainbow, that one times that one. 3 times 1 is 3, positive 3. Remember to include the sign. And they've got to add together to make minus 4. And the factor pair that times together to make +3, but adds together to make -4, is going to be -3 and -1. So -3 and -1 multiply together to make +3 rather, but add together to make -4. So we're now going to split it. Let's put our -3x on this side and our -x here, so that we've got a common factor of 3 here. Take out a 3x, leaving us with x minus 1. Take out a -1, leaving us with x minus 1. Those two match, so therefore the other bracket is 3x minus 1 times by x minus 1. So now we have found all of our factorized elements. We can now bring that together, and we can say that this expression from the question can in fact be rewritten in the following way. X minus 1 times by x plus 1 all over, oops, that's the world's worst bracket denominator division sign there. There we go. All over this one here, which is this one here, which goes to x add 4 times by 2x minus 1. And that is multiplied by this one here, which is this one here, which goes to 3x minus 1 times by 2x minus 1, all over the final one with this one here, which is our 3x minus 1 times by x minus 1. So now we've got it all factorized. It's just a question now of cancelling out all of the various terms that can cancel. So let's have a look. We've got x minus 1 there, x minus 1 there, so they can cancel. We have got 2x minus 1 there, so that can cancel there. We've got 3x minus 1 there and 3x minus 1 there, leaving us just with x add 1 and x add 4. So that is equal to x add 1 over x add 4. And that's as far as we can go. I should point out that every now and again, you do get students who wonder if you couldn't like cancel that down like that and write it as a quarter. I'm going to put a big cross through that because that is highly illegal maths, okay? And you know, the answer to that is you couldn't do that because of the way you've got a plus here. If you have an addition or a subtraction here, if you try to do that, you're changing the value of the fraction. So just a note, I'm sure a lot of people are clear about that, but every now and again, sometimes students do wonder, could I further simplify this by now cancelling the x? And the answer to that is no way, you certainly could not do that, okay? Right, well, that was the first of those two questions. I thought we'd do a couple in this video, so let's have a look at the second one. Okay, here's our second one. Right, what have we got? We have got a cubed minus 3a squared over 8a squared minus 4a, and this time it's divided by a squared minus 9 over 2a squared plus 5a minus 3. Well, let's do the 2a squared plus 5a minus 3 first and get that out of the way. So it's our old rainbow split method. There we go, multiply that. 2 times by minus 3 is minus 6, and they've got to add together to make plus 5. So we're looking for two numbers that times together to make minus 6, but add together to make plus 5. So let's think about our factor pairs of what it could possibly be. So we've got 6 and 1, and we could have positive 6 and minus 1. Let's check that. So plus 6 times minus 1 does make minus 6, and plus 6 add minus 1 does make 5. So that's our correct factor pairing. So we're going to do having done the rainbow, it's now time for the split. So we have 6a minus 3, and we have minus a here, and 2a squared. So we're now going to take out a factor of a here, leaving 2a minus 1. We're going to take out a factor of 3 here, leaving 2a minus 1. We know this is correct because these two match, and whatever's in front is our other bracket. So we have a add 3 times by 2a minus 1, and that is that one factorized. Let's think about the other elements. Do I need to actually, you know what? Let's now talk about KFC. KFC, as it's so often called by teachers, keep, flip, change. I'm not quite sure. It's a bit of an acronym. I'm not sure it necessarily works that well, but basically when we've got a divide, you know which way your teachers taught you when you were learning this back in 7 or 8 or year 6 or whenever it was. So what we basically do is we flip, and we change. I think that's where the KFC comes from. So when we're trying to divide two fractions together, we need to take the reciprocal of this one and change that into a multiplication. So we're going to write that as a cubed minus 3a squared over 8a squared minus 4a times by 2a squared plus 5a minus 3 all over a squared minus 9. All right then, so now what have we got? Well, we've just factorized here in our little side note, we've just factorized this quadratic. So we know that that factorizes into a add 3 times by 2a minus 1. Perfect. Right, let's turn our attention now to the denominator of this one. A squared minus 9, that is the difference of two squares. Again, some teachers like to call that dots. I often have students saying, oh, it's dots, dots, but they don't know what dot stands for. So it's the difference of two squares. So that is going to be a add 3 times by a minus 3. Perfect. We've dealt with that. We've dealt with that. Let's turn our attention to over here. I think we could just factorize out an a squared from this. So we're going to have a squared times by a minus 3 there. So we've now dealt with that one. Here, shall we take out a 4a? So 4a, open brackets, leaving us with 2a minus 1. Okay, so we've dealt with that one. So now it's time for cancelling everything. We're safe to cancel because everything's multiplied together. So what have we got? An a minus 3 cancels with an a minus 3. Remember, it is okay to cancel across separate fractions as long as you have a multiplication there. That's perfectly fine. We've got 2a minus 1, 2a minus 1. We've got an a add 3 and an a add 3. We've got a factor of a there and there. So that whole thing simplifies down to just a over 4, which is the answer to that second one. I hope you found that helpful. That was just a couple of nice questions on just simplifying algebraic expressions. Relevant for GCSE if you're aiming for like grade 8 or 9, and an essential fundamental key skill that you should already have in place for A-level. See everyone in the next video.